well. So yeah, we're good.
Hi. Hi, Xingli. How are you?
Thank you.
All right. Hi, everyone. Welcome back. So we're going to have the lightning talk session where each speaker will get at least 8 to 9 minutes to talk about something interesting. And we'll kick off with Dave talking about finding chicken and beer.
As Mark said, I'm Dave, and my talk is about finding chicken and beer near me. So, you've had a hard day at Apricot, you're sitting in your hotel room and you're going, you know what? I really could go with some fried chicken and beer. Up pops an ad. How convenient. This is great. Then you click on the ad and you go, well, hang on, this is nowhere near me. I'm here in Petaling Jaya, and this is all the way over in Kuntan. How did this happen? Well, it's not going to help me. This is not friendly to me. This is of no use. So I look at my IP address and it just gives me this location of Malaysia. Not very accurate. So how can we fix what's actually going on? RFC 8805 is a way of actually assigning address prefixes to specific cities, towns, places, etc. So this is published through a CSV file, and it's attached to a geofeed attribute that is in your Whois records. So an example would be inetnum here, and the geofeed would be the link to the geofeed file. So pretty straightforward. The data we put into this geofeed file is the prefix you want, optional country code. At this point, after the prefix, everything is optional. So if you leave out all the information, then you don't want to publish geofeed information. So these are all based around the standard country codes, country region codes. The city, they would like that as the city name is written with capitalizations as they should be. And again, the postal code is optional. This is also useful for providers of other geofeed services, so the likes of MaxMind and Co, who use that data for not just chicken and beer ad delivery, but also for streaming services. Operators in the room, you've all felt the pain of having to contact each individual streaming service to get your customers in a particular city getting access to things. So this fixes a lot of these problems. So help me find chicken and beer in a city near me and update your geofeed data, please. Told you it was going to be quick.
Any questions? All right, so next up we'll have Taiju-san talking about the Janog 5.55 network.
Hello, my name is Taiju. I am an undergraduate student at the University of Nagasaki. I will talk about the work of the Danog 55 Backbone Team's leader. I will tell you why I become a leader. I have three reasons. First, I have a member of the Danog 54 Backbone Team and had experience. Second, decided to use the University of Nagasaki backbone. I communicated with University of Nagasaki and Danog 55 backbone team. And last, I know the another leader and we are good friends. This is the biggest one. It's more fun and efficient to read with a close friend. I will talk about actual activities next. Selecting the member of the team is essential for the project to proceed. Our select policies are many beginners. People near the Danog 55 venue are little professional. We hoped to bring the joy or backbone to many beginners. One of the beginners had never used a router. For this purpose, we have prepared a number of study methods. It's the basic of networking. We used PowerPoint to explain various technologies like physics and routing. Building a learning infrastructure. We prepared container lab and real device so everyone could freely run and use various OS. We made a strong focus on creating a place where people can feel to ask questions. Now that we have our best members, the next step is to build backbone. The venue was Kyoto, Japan, and the closest pop that the University of Nagasaki had was Osaka. We needed to connect Kyoto and Osaka. There were two ways. Decided dedicated line or VPN to NGN. And we choose VPN to NGN because of the price. There were many other things that needed to be decided, but the beginners members handle all of them. For example, how to connect, what device to use, and so on. Leaders and professionals only gave advice. And so they have completed the network topology. A lot of traffic goes out of transit from Kyoto to Fukuoka via Osaka. The remaining paired routes exit the IXPs. Next, I talk conference days activities. Pairing was done with various organizations. We made a request to many people before Danog 55 and input configuration on Danog 55 days. The purpose of pairing is for money? No. For traffic control? Usual. Our pairing purpose is study and communication. We did this to train beginners and it was used for on-the-job training in the partner organization. Not everything was perfect. First incident is lost location to the monitoring system. This was because of the ACL in the core router. Second incident is that the core router can't resolve some routes. This was because we didn't include IBGP Next Hop Self in the configuration. However, we overcome many obstacles and successfully provide a Wi-Fi network. Finally, of course, building a perfect venue network is important. But more importantly, I believe the most important thing is for the team to enjoy and learn. Thank you.
Any questions for Taiju-san? All right. We'll then move on to Xingli, telling us about his CERNET to CERNET 2 to CERNET 3 migration.
Okay, good afternoon. So this is a brief report. Actually, after 30 years, we have 3 networks: China Education and the Research Network, and the CERNET 2 and the CERNET 3. The first one, actually, 30 years ago, we ran IP over X.25. It's only like 2.5K. Then it's 64K over IP over lease line. And because of monopoly in China, at that time, you cannot get any lease line speed higher than 512. So we got funding to build a VSAT network, asymmetric, downstream 4 Mbps and upstream like 2. And then later, actually, in the year about 2000, we ran IP over SDH. We got dark fibers there. Okay. Then upgrade to DWDM 10G. And the year 2014, we upgrade to 100G. So that's CERNET IPv4. Also because CERNET is for the in-series students in China. And the total number of students is about 320 million. And by that time, we realized no way to get one public address, v4 address per student in China. So we start IPv6 project, originally connected to 6-bone. And then later it's another backbone, and it is IPv6 only backbone. So by the year 2020, it's also upgrade to 100G IPv6 over DWDM. And that's the IPv6 only. Then for every decade, we have to play something new. And the third is CERNET 3, which also IPv6 only, but it's a heavy sliced network. There are about 4,000 slides. So those are the features for that. For CERNET, that's AS4538, IPv6 only. And the total prefix is about /8, thanks to APNIC. CERNET is funding number of APNIC. And the links is multiple 100Gs and 38 POPs in all provinces in mainland China. As customer is about 2,000 universities. And the user is about 30 million. And appearing actually in 12 cities in mainland China, for example, Beijing, Guangzhou, Wuhan, Shanghai. It's pairing with China Telecom, China Unicom, and China Mobile, free settlement pairing. Also, we have POPs in Hong Kong, in US, and some kind of direct link to Europe. So it's to global community tier 1 networks, as well as academic networks, for example, GEONT in Europe and the Internet 2 in the United States. And the CERNET 2 actually is IPv6 only. The main AS is 23.9.10.100. But each POP has its own individual, independent atomic systems, because by that time we try to do multi-homing test. And there are multiple /32 prefix. And the links and the customer. All the CERNET universities are also the member of Cernet 2. And okay, that's the period. The unique feature actually is even Cernet 2 is IPv6 only network, but we deploy IPv4, IPv6 stateless translation, which turn into the RFC 6052 and the 7915 extra. So that's the thing. So Cernet and the Cernet, part of the Cernet 2 IPv6 address through translator can reach global internet either as a client or the server. And for Cernet 3, actually, it's also IPv6 only, but based on all kinds of slicing technologies, for example, like VRF, VPN, or SRv6, or those kind of things. So there are 4K public atomic systems. When we turn on this, actually that's crash Internet 2 routing table because there is the number of prefix limits. We fix that. And each slide, actually we have a /32. So in total is a /20 IPv6 prefix. And the customer actually, that's the research groups, and the vendors, for example, Huawei do something and the China Telecom do something for that. And the unique features actually, there are three. First is similar to Cernet 2. It's translation between V4 and V6, but it's distributed in all POPs. And also, our NOCs has facing big challenge because usually the NOCs configure routers and another group configure clouds, but this Cernet 3 is combined. Each POP we have a big cloud. So the NOCs has to learn how to configure routers as well as the VMs. So that's a big challenge for them. Another interesting thing is actually collaborates with China Mobile and Huawei. We turn on 1.2T router interface from Beijing to Guangzhou. It's about 2,000 kilometers. Actually, the WAN is 400G because they do not have OTU for 1.T interface. However, Huawei router has the single port support 1.2T. So that's something interesting we like to use for maybe distributed transformer trading or something. So finally, interesting operation issues for Cernet 3. Managing multiple slides, that's a big, big challenge. And the second, as I mentioned earlier, managing distributed clouds or VMs. Because we want to do measurement for each slide in 40 cities and for 4,000 slides. So it's 4,000 slides multiple to 40 POPs. So at least you need have this number of virtual machines in order to a matrix of performance. Also managing distributed stateless IPv4, IPv6 translators because some slides want IPv4, but it's IPv6 only, so the translators. Also quick deploy and destroy instance, and finally try to some large language models and help NOC for deployment. But that's a lot of fun, quite difficult, but fun. So thank you very much.
Thank you, Xingli. Any questions for Xingli?
Thank you.
I have one actually before you go. You say China Mobile is China Mobile is providing the optical underlay.
Yes.
Okay.
Yeah.
And you
Huawei is the equipment.
All right.
And we run it.
Interesting.
So,
Okay. So next up we'll have Moit to talk about his IPv6 migration at NITK. Thank you.
Hello, I'm Mohit. I'm working as an associate professor in the Department of Computer Science and Engineering at the National Institute of Technology, Karnataka, Surathkal. It's in the southwest region of India, just near to the Arabian Sea. Before I get started, I would like to acknowledge that this project, migrating NITK Surathkal campus network to IPv6, has been funded by the APNIC Foundation. And we faced a pretty unique challenge as soon as we started the project, because once the project was awarded, we actually wanted to hire a few network engineers who can come and work with us on migrating our campus and help us in the IPv6 deployment. But in that region of India, we did not find quite a few people who were experienced with IPv6. So the thing that we have done to solve this problem is that we started training our own students on IPv6. And I'm happy to report that the entire migration process that I'm going to talk about is totally done by students of our own campus. And I would like to take a special moment to acknowledge the help that I got from two of our alumni students, whom I have given the credits for helping me put together this slide deck and also helping us throughout the entire project right from the beginning. So this is our campus. We have about 25,000 devices in the campus. And as I said, we are right across the Arabian Sea. I can have a sea beach view from my office when I sit and work on these topics. And yeah, this is a high level outline of my presentation. This is our team. This project is jointly operated by NITK Surathkal, and we are working together with India Internet Engineering Society. We have one network engineer, but most of the other members are the students, undergraduate students, and also the alumni who have graduated are helping us out in this migration process. So the purpose of putting together this lightning talk is multifold. First is we wanted to tell some of the observations that we have seen. Second is, since we are among the members who work with the live network day in, day out, if you see we have done something incorrectly that we should have done in a better way, I would like to talk to you and know from you so that we can improve it. As I said, this is a purely academic effort. Any inputs are welcome. So please feel free to talk to me after this session, and I'm happy to discuss if there are ways by which you believe we can improve our work. So I have mainly 5 observations. I have tried clubbing them together into unique topics. So first topic is we observed something related to the router advertisements. The first thing that we observed was that even when we were setting, these are all the observations in the Linux kernel. So when we were actually setting accept router advertisements to be false, we noticed that our machines were still accepting the arrays and the routes were actually getting installed in the kernel. So we identified that it was a systemd network related thing. It has its own routing table in the kernel. And by default, the configuration in systemd kernel we observed was to accept arrays. So even if we set the arrays to be false using the sysctl, it actually did not work. We had to actually go and disable it in the systemd network. We also have, as I said, 25,000 devices, and most of these are students. And my network is having students who are the top-notch students from India, and we have to control their excitement as to what they do in the campus network. So some of the students or some of the people actually can put up their own devices, and they can run their own router advertisement daemon, and they can actually broadcast arrays. And that happened with one of our devices. In one of our devices, we noticed that this device was accepting router advertisements from an unknown source, from where it shouldn't have actually accepted those arrays. And ultimately, it ended up losing connectivity for that device. So we had to actually set up our ACLs appropriately to actually resolve this issue. But we have still 2 questions that we have not been able to answer, which are posted over there. How did this device end up selecting the route only for specific hosts and addresses? We have no clue. We are still debugging that issue. And also, why did systemd network fail to identify the packet losses happening on that route, and why it did not fall back to another route, given that there was another route still available? So we are still doing that diagnosis. We haven't still been able to answer. If you have any inputs regarding this, please feel free to let me know. The second one was support for dual stack. Our network uses captive portal from the firewall vendor. And one of the things that we noticed is that it did not have an active dual stack support. So when our devices were authenticating using an IPv4 address, the corresponding IPv6 address related to the device was not being captured. And certain websites don't support IPv4. So we, being an academic institution, we use 2 things very commonly. One is overleaf.com to write papers, technical papers, and 2, Stack Overflow for solving our technical resolutions. And both these websites do not support IPv6. So many of the times when our students were connecting on other websites which support IPv6, the captive portal will log IPv6 address. And when they try to have a fallback on IPv4, the captive portal will pop up again and say, you need to sign in again. So we had to report back to the vendor but they are yet to give us a fix. So for now, we have disabled the captive portal, and currently we are using 8021x authentication in terms of eduroam deployment. So we did eduroam deployment coupled with IPv6 deployment in a single shot. Second thing we observed was Kubernetes. We have a Moodle deployment for LMS, and we observed that the older versions of Kubernetes, which were less than 1.21, did not actually have proper dual stack support for IPv4 v6. So temporarily we solved by performing a manual recovery, and actually our entire cluster lost connectivity when it picked up an IPv6 address and gave internal host the IPv6 addresses. And finally, we have upgraded the Kubernetes version, and then it has been working fine. The third observation is related to the address assignment, particularly related to DHCP v6 on the tagged VLANs. We noticed that the clients were listening to all the tagged VLANs on a particular interface, and they were obtaining addresses from multiple VLANs. So we observed this problem in Windows as well as Linux, and we also saw the community discussion, and we found that actually Windows says that it's a feature and not a bug. And actually this is being actively used in the SMB file shares. Fix was for Linux was actually pushed in versions greater than 5.15, but we are using kernel versions more than 6, and we are still observing these problems. So we need more efforts to actually identify what's going wrong. And we identified there were problems with privacy extensions. We saw that temporary dynamic addresses were there in our testbed, which we have set up. We also written a manual on how we set up a testbed. So we actually set up a testbed first when the project was awarded to us, and then we went to the actual migration. We have an APNIC blog in which we have explained and put up the PDF that shows how to create a testbed. And this was pretty difficult for our network administrators to track, because we saw that these addresses were temporary, and we were able to identify that these were IPv6 privacy extension related problems. So we actually recommended our network administrators that let's better use only DHCP v6 with RA, so that we have the gateway to be known, and disable the add autonomous flag. We also have static routes on our core switch. And for some reason, if our core switch rebooted, we observed that the static routes just wouldn't work. So we had to manually remove these static routes, add them again, and then it would work fine. And we still have no idea why this is happening. So the root cause of this behavior is not known. Maybe it is vendor specific. Maybe it's something that we didn't do it correctly. We still need to find out. And we also noticed that whenever IPv6 enabled routers go down, the IPv6 connectivity re-establishment takes several minutes. IPv4 doesn't. IPv4 connects pretty fast. So long as we are on dual stack, our people don't face too much of downtime. But if we were to go towards IPv6 only, this would be a challenge, because the re-establishment would actually end up taking minutes. And the last slide about some miscellaneous observations. Some of them are vendor specific. For example, our firewall web filtering vendor had no support for IPv6. We also saw that in one of our devices, the main devices, the BGP support for IPv6 was lacking, particularly missing support for RTR, for RPKI. We have also performed RPKI validation, and we also are running currently RIPE Atlas probe in this network. Support for monitoring BGP v6 was not available. IPv6 and MAC binding was not possible. There's also lack of support for IPv6 in some network debugging and monitoring tools like HPing3. We also saw that there was lack of support for DHCP v6 and Android, and for that we had to go around with RDNS as a solution. But that also means that if your device is old and doesn't support this RFC yet, you wouldn't be able to solve the problem for the Android users. And of course, we also found there was no support for IPv6 on some important proxies, the most important proxy being some federations that are actually supporting eduroam. And I see eduroam is working in this campus, in this venue as well. So these are some of our observations. We are happy to talk about it. Again, I would like to acknowledge ICF Asia and the entire team for funding this project. Thank you very much.
Thank you, Mohit. Any questions? Nope. All right. Thank you so much. Next up, we'll have Aftab giving us some RPKI.
Hello, this is Aftab Siddiqui. Thank you for staying so far. I don't have anything related to IPv6. Normally I talk about RPKI, but this is a step beyond that. I'm presenting it on behalf of, I work for APNIC Foundation. I'm presenting this on behalf of ISOC and Erin. It's a project initiated by them, which I was part of previously. So I want to carry on and finish it and present it to the community. This is the first part of the consultation. We are trying to understand, number one, question, how many of you have heard about RPKI sign checklist? That's not encouraging, thank you. That means if I ask you to do the survey, you will leave on question number 5 that I don't know about RPKI sign checklist. So my first point is, let me tell you about what is RPKI sign checklist so you can do the survey properly. RPKI used for various things. Well, only 2 things at the moment. It is for, you create ROAs, and if it becomes a RFC at some point in time, this year or coming years, you'll be able to create ASPA. At the moment, you can only create ROAs. And what you do with ROA, it is an attestation that, well, whoever is announcing this prefix from this origin AS can be validated, that of course, that is authentic. It is just an attestation. So who can create those ROAs? Well, we all know that if you are the holder of those resources, only you can create that. So using the same framework, it was proposed a couple of years back that, well, you can sign anything else, any document, any text file, or whatever you like. Because RPKI is now supposedly a trusted model, so then it can be used for other things as well. And that's how the RPKI sign checklist was born. It is the format is defined under the RFC 9323, if I'm, yes. It's not very old, came out in 2023, and I can't see Tom here, but he is one of the author of that, along with Job Snyder and Ben Madison. So there's an extensive discussion on the mailing list, on the pros and cons of that. And they have highlighted few use cases that how it can be used and how it cannot. The idea is simple, as I explained. RIR has to provide you the feature because in most of the cases, you give your certificates to the RIR, respective RIR, to keep it to themselves to make it easy. So you can still use the same model and then put any file, any PDF, any text you want, and then sign it with the same certificate. And then you can share it with anybody else. And then the other party who you are sharing it with can verify. There are some basic differences between the existing RPKI model we use for ROA, and that is you get the public repository. You can download all the ROAs and then verify all the certificates and say, okay, fine, I have the repository. Of course, because it is for global routing table. But it's for the RPKI sign checklist, the repository has to be, and as defined in the RFC, it must be private because you are sharing most likely some confidential data. And one of the use cases which was discussed quite extensively is the replacement of LOA, which is letter of authority. If you recall from last year, if you are regular at Apricot, I did a survey on LOA, whether LOA is important or required after replacing it with ROA. So this is just a continuation of that. So these are some of the steps you can, it will take to create an RFC object. And then once it is created, you can send it to whoever you want. We have mentioned a couple of them, cloud providers, which offer you bring your own IP services. Right now, we checked a couple of the cloud service provider, and they right now only ask for a ROA. But I have only checked only 2. Our plan is to check as many as possible. But other transit providers at the moment, they do ask for all LOA. So we are planning to provide them whoever asks for LOA and give them an RSC and see what they say about that, if they are able to verify it or not. Distribution can occur via, at the moment, it's just you get the file and then you can send it. You can send it via email, you can send it via any API, but you have to do it on your own. Or just send an USB. I think everybody's going to connect that USB in your laptop. Once the third party receives it, they can verify it with the hash you provided them. Okay, fine, this is valid. The PDF you have sent has actually been created by the resource owner or the holder in our terms. So that verification exists. There are some problems, of course. No system can verify what is the content of that PDF or the text file. No system can verify that information. You can put some gibberish in it, but and it will just say, yep, this file is valid or validated. But the idea is you are providing that file or that content to the third party just to make sure, just for the verification of your resources. If you are providing that, of course, you're not going to put any gibberish in it. So that's the whole idea. So saying that, I need your help. If that information was good enough for you to understand what RPKI signed checklist is, in short, RSC, can you please do this survey? And if you need an extra t-shirt, I'll give you that. And whoever done it first will get an extra hat. I also have a hoodie. So pick and choose. That is the only way you can get surveys in this community. I have learned it in the last 15 years, right? So please provide honest feedback. If you still not clear about the RSC, there is an exit path in that survey. You can click, no, I don't know about it, and you'll be out. That's fine. That is still a valid response. But try to give it as much as possible. So that is all from my end. Thank you so much. If you have any questions.
Yes, question. Hello. Thank you, Aftab. Hisham Ibrahim, RIPE NCC. I'm a techie, so I get the technology and I like it. I am not a lawyer, and that's why I'm saying what I'm going to say. I'm not the best person to debate this, but I understand that there might be some issues with some regulations that would be introduced for an RIR to do something like this under, well, in Europe, EIDAS and stuff like that. It's good that the techies talk to people that are doing the regulation stuff, because it puts the RIRs in difficult positions if they're being asked to do something like this when the regulation cannot. I'm curious to hear your thought.
Thank you for bringing that topic. We have 11 questions for lawyers, which we're going to ask separately. Because after talking to RIRs, we said, well, that is a good idea. Why no one implemented it? We said, lawyers. So we are trying to understand. There are two questions which do ask the techies, do you see any legal issues in the whole setup? And apparently there are some legal issues in it. So it has to be verified and reviewed. That's why all RIRs did not move ahead with it. Some have some testbed available. I have tested at least 2 RIRs. So they do have some working principle available, but of course, there is a larger consultation required. I mean, putting a lot of effort and then told by lawyers, okay, it's not going to work, doesn't help, is not helpful at all. So yeah, I totally agree. There are a lot of legal barriers in it. It may sound technically feasible, but the use cases or the effort to develop it and the legal hurdles to jump over might be a big roadblock. So yeah.
Very quickly, for the record, because there was talk about geofeeds, there was a long discussion about that and privacy discussions about the database as well. So just because it's the second talk, that's why I'm going to the mic and mentioning this. But thank you.
No. That's. I mean, and there was one point where we said, okay, why can't we make it a public repository? And everybody said, no, absolutely not. It has to be private. And then it becomes another problem. So as the RFC said, it must be private, because we have to follow that as ITF said it. So that's all from my end. Any question, I'll be available. If no questions, you have to ask a question to get a t-shirt, remember. Thank you.
Thank you so much. Next up, we'll have Shishio-san to talk to us about DDoS mitigation at layer 2.
Hello, my name is Shishio Tsuchiya, SE lead of Arista Networks Japan. My presentation is the DDoS protection by the layer 2 switches. Next, please. Oh, Tinker. Okay. Yeah, DDoS always changing. DDoS always changing, and the traffic volume is significant today. And how to protect the DDoS on the service provider network? RTBH, remote triggered black hole, is most popular technique on the ISP network, as you know. And this is RTBH. We configure route map and next up to the black hole. And if we attack the host in this route, then the next up the null zero. And it propagates to the network wide. And so the router attack the host route block to the null zero. And RTBH could protect from DDoS for the attacked host, but it would be affect on the non-DDoS traffic like this host or other services. And BGP flow spec. BGP flow spec defined flow can be in the flow like source prefix and the destination prefix, and layer 4 port like this one, and also defined action drop or redirect towards the machine. And it can protect by specific flow DDoS without affect normal traffic. We are rethinking DDoS character and IP access race. DDoS is IPv4 or IPv6. It is not MAC or not layer 2 protocol. Modern layer 2 switches can be configured layer 3, layer 4 ACL on the layer 2 switches port, as well as layer 3 routed port. Then it could be a helpful flow spec on the layer 2 switch, layer 2 port, we think. So we had a small enhancement, but I believe it is very significant for the service provider and the carrier Ethernet. BGP can use ACL configuration orchestrator on layer 2 switches as a northbound protocol. It's also applicable for the VPLS and EVPN layer 2 VPN network edges. We can just configure the two this CLI. Then it works BGP flow spec on the layer 2 port. My presentation ended. Thank you for your attention.
Thank you, Shishio-san. Any questions? All right. Thank you so much. Next up, we will have Yoshikawa-san. Community activities as a non-profit research ASN.
Hello everyone, my name is Tomoki Yoshikawa from AS 59105 Homelock Operators Group. Okay, let's start. What? Okay. First of all, let me introduce myself. My name is Tomoki, and I'm a fourth-year student at Kyoto University in Japan. And I belong to AS 59128, Kyoto University Microcomputer Club. It's a club activity related to computer in university, and each members make PC game, music, web application, and network. 2 years ago, I put Cyberark in a clubhouse, yes, this Cyberark. But many members say to me, it's very noisy, but it's very cool, I think. Yeah. And I belong to Homelock Operators Group AS 59105. I'll explain the details later, but my role is peering and AS operation. Okay, let's start. Background. There are several problems in Japan's network field. One of them is shortage of young network engineers. It's because the popularity of applications and cloud services is increasing. However, the demand for network is also growing, such as AI platform, streaming service, and so on. Why is the network field not popular? I guess it's few opportunity to run operations in a production environment. I think many people are interested in the network technology, but even if they have network knowledge, there is no environment to use them. Also, even if they have technical skills, there is no connection points and no knowledge how to be allocated resources. I think these problems are reducing interest in the network internet field. And I want to solve these problems for future internet community. So we aim to provide a playground of network. Next, our group is HomeNock. HomeNock is a research network and non-profit organization for running network technologies related to the internet from 2015. Members can use IP transit or internet connectivity with our IP addresses for a low membership fee, and it's free for students. We have over 150 members and an average of about 1 Gbps. Our committee consists of 4 working network engineers and 5 college students like me. We aim to contribute to the education of young engineers and the internet community. This is our activities. We have hosted both at Janogu Japan Network Operators Group 4 times in the past. And at Janogu 55, we discussed the operation of this experimental network. Also, we built our POP network connection point at the University of Fukuoka with students. Also, we participated in Asia Peering Forum 2024. We met a lot of peering partners and took part in peering personal. Furthermore, we connect to BBIX Mania last July. We want to contribute to Asia internet community. So this is our first step. Next, we participate in Apricot 2024. As a member of the internet community, we engaged in discussions and idea exchanges. Our achievement, I guess we have created a new community. The users exceeded 150, and many people discuss issues at events or Slack. And we can provide learning opportunities for youngers. Of course, it's knowledge of AS operations, IX, and data centers. And I can get acquainted with many people in this field. It's very vast. Next, I'll explain a learning research ASN. In BGP Tools side, there is a tag of personal ASN. These ASNs are run by a single or very small group of people for either hobby, educational, or infrastructure niche. There are many personal ASN in LIPE, over 800 ASN, but in APNIC about 250 ASN. It was increasing the number of personal ASN. Okay. By the way, what is benefits of running research ASN? Of course, it's AS operational experiments and knowledge. It's lead to interest in the internet, especially for young people. And as a member of the internet community, they can contribute to the internet. I think it's very important difference from the closed network, such as DN42. And new communities lead to the development of the industry. It can also bring new perspectives to existing communities, creating positive impact. So by increasing the number of learning research ASNs, we might be able to attract more young people to take an interest in this industry. Our future. We will continue to actively contribute as a member of the internet community. And we want to establish a presence in the Asia region and contribute to the development of the internet in Asia. Also, we'd like to collaborate with organizations in Asia engaged in similar activities to increase the number of running research ASN. So, if you are interested in our activities, please contact us. Conclusion, I introduced the challenge and initiatives related to engineer development. As one example, I explained the usefulness of running research ASN. We'll continue to contribute to the development of the internet as a member of the internet community. Thank you.
Thank you. Any questions? Tough crowd this afternoon. Must be really cold in here. Thank you so much. Next up, we will have. Oh, is there one question? No? Okay. All right. Thank you. We'll have Shishio-san again to talk to us about LPO, linear pluggable optics.
Hello. Okay, Shutsuya again. It's read of Allison to Japan. Okay. Next presentation title is LPO, linear pluggable optics. This is the optical module, and the RX side of the optical module use convert optical signal to the electronic signal, limit the conversion, send the clean 0 and 1 back to the switch file. Each of generation that SADES means serialization and deserialization between the switching ASIC and optics required more complex processing. 10G NRZ limit amplifier and 25 NRZ CDR and 55 PAM4 use the DSP. 100 PAM4 required DSP. Continued increase in power consumption. Optics power draw will grow greater than the system power when the full field with 800 GHz optics. This is the switch technology increasing. Switch silicon technology increasing the double per 2 years. In the 2022, 400 GHz optics was released. Switching silicon using 7 nanometer processing technology, which supports 64 by 400 GHz port on the single chip. The single chip, the total bandwidth is 25.6 terabps. And in the 2024, 800 GHz optics was released, and switching silicon supporting 64 by the 800 GHz, and also using the 5 nanometer technologies, processor technology. The total bandwidth is 51.2 terabps. In the 2026, we expected 1.6 terabps optics will be released, which use 3 nanometer processing technology. Total bandwidth single chip will be the 102.4 terabps. So now today is 2025. Broadcom already released a Tomahawk 5 chipset, which is a 5 nanometer processor technology, and we and other switch vendor also already released 64 by 800 giga optics system by the total bandwidth is 51.2 terabps. We already released this one. And the performance evaluation of programming optics, energy consumption for the transmit of 1 bit is decreasing by the processor evolution. But power requirement per module is increasing each of generation. So there is some solution reduce energy consumption. CPU is we have a 3 approach: programmable optics and CPO, co-packaged optics, and linear drive programmable optics, LPO. CPU is most low consumption, but it requires dramatically change over ecosystems. LPO would be one of a suitable solution for the 200 bps range SerDes, which means 1.6 bps and the future. I'd like to explain the LPO in detail. The switch 5 now has a DSP. Second, in the module isn't need. DSP-based SerDes in the Jericho 3 and Tomahawk 5, which is a Broadcom switching silicon. LPO will be support 800 gig two-way FR4, XDR8, and the AOC. Module component cost and power saving. LPO is 8 watt vs 140 to the 60 watt DSP. And modular runs cooler, fan runs slower, the cubic fan load saving. LPO MSA, LPO solution achieve significant power saving by the removing the DSP function from a programmable optics module. Optimize power, cost, and latency while maintenance flexibility of programmable optics. Focus on LPO MSA is a specified module and network equipment level interoperability requirement across both electronic and optical technology. Start with 100 gig SerDes. Power bill saving, LPO at 8 watt, and one system is support 6-4 LPO. The fan saving is 150 watt normal. And life cycle, if we consider the life cycle will be 5 years, then the total saving is around. This is sample of cost reduce. Summary is significant reduction is LPO achieve a significant reduction in power consumption, low latency and reduce module cost compared to the DSP-based solution to meet and exceed the link reliability requirement. 100 gig SerDes operations scalable to the 200 gig SerDes. Enable the broad ecosystem of the LPO module manufacturer and the LPO enable network equipment. My presentation ended. Thank you for attention.
Thank you, Shishio-san. Any questions for Shishio-san? I've got one, maybe. In terms of reliability, so obviously, if the DSP on the switchboard fails, that's you have to replace the whole switch. Yes.
Reliability.
Reliability of the DSP on the board itself. If that's an issue, then it obviously will affect all the ports, right?
Yeah.
So you have to replace has that been something that the MSA have worked on?
Yeah, I think LPO MSA already published some interoperability tests, and they defined some white paper, and they will publish some spec of LSA, I think.
Okay, thank you.
Question. Is there a potential to do forward error correction using the DSP on the switch? FEC.
Excuse me.
Forward error correction. FEC.
Error correction on switch. Yeah. I think this is the error correction on the switch because in the switch, ASIC already supported PHY internal. So error correction do the switch, I think.
Thank you.
Yeah, I think yes. So I think some of the switches would have FEC already as part of the host. But yeah, I think there's the additional FEC functionality in the DSP could also be offloaded, I would imagine. It's quite interesting because then you're just going to reduce a lot of heat from not having the DSP in the plug.
Thank you. Thank you.
Thank you so much, Shisho-san. Our final speaker would be Giacomo Piccolini, talking to us about something secret that we don't need to know about, but should know.